In this video, we're going to cover section 7.5, and we're going to still be solving trig equations just like we were in 7.4. The big difference here is our angle is not just x or theta. It might be a little more like, say, 5x or 2x minus pi over 4. So as what we're going to see is we're going to solve these in almost the same way. I want us to go ahead and isolate that cosine of 5x. And so to do that, we just need to subtract by the square root of 3 and then divide by 2. All right, and so the idea is we want to then go look at our unit circle and see what angles make cosine into minus the square root of 3 over 2. And so the two spots that we're going to find here is we're going to find, let's see, let's just go look. Okay, so minus the square root of 3 over 2. So here's one spot. Okay. And let me make sure. Here's our other one right here. So we have 5 pi over 6 and 7 pi over 6. These were the two that we were looking for. Okay. And it's not just these angles that make cosine minus the square root of 3 over 2. It's anything that's coterminal with them. Now, this is what I want the inside of cosine to be equal to, is one of these mini angles. And so what I'm going to do is I'll just set the inside of cosine equal to those. Okay. And so from here, we just need to divide each side of the equation by 5, and we will have our solutions here. So dividing this first one by 5 on each side, we're going to get a pi over 6 plus 2 pi k over 5. Okay. And similarly for the second one here, if we divide by 5 here, we're going to get 7 pi over 30 plus 2 pi k over 5. Okay. So not a whole lot different. Okay. That these two formulas will give us every solution to the equation above. And if we want to find specific solutions, we can just plug in integers for k. So the things that could go in place of k are essentially whole numbers and their opposites. So we could plug in things like -3, -2, -1, 0, 1, 2, 3, so on. Okay. Let's check out the next one. So this time the angle looks a little bit more complicated. This is going to add an extra step to our work here. But we want to find the angle or angles that make y over x equal to the square root of 3. Okay. And so one option here is that y could be equal to the square root of 3 over 2. And that the x could be, say, 1/2. There we go. All right, so let's go find on the unit circle where this happens. Do remember with tangent, we are going to always end up with multiple formulas, just like with sine and cosine. However, when we do get our two formulas here, they actually create the same list of numbers, which is not what happens for sine and cosine. Okay. And so what this means is with tangent is we only need to write one of the two formulas down that give us our solutions. We don't need to write them both. Okay. So if we come over to our unit circle, we can now find the location where y is the square root of 3 over 2 and x is 1/2. And that is at pi over 3. So let's take care of that. We want this 2x minus pi over 4. We'd like it to be equal to pi over 3. because that would make tangent equal the square root of 3. But also, tangent does have a period of pi. So if I add pi k to this, that will create a new angle that will make the inside of tangent be equal to something that makes tangent equal to the square root of 3. Yeah. So now all we need to do is solve this equation here for x. Let's begin by adding pi over 4 to each side. And so do note that we are going to be combining the pi over 3 and the 1/4 because they are going to be like terms. And so this gives us 2x is equal to 7 pi over 12. Okay. And we don't want to forget, we did divide pi, or we did add the pi over 4, but we still have this pi k over here. Okay. And then to finish solving this for x, I just need to divide each side of this equation by 2. And so we get x equals 7 pi over 24 plus pi k divided by 2. And so all of our solutions will take this form right here. All right. So I have another one here for us to try, and this one should look familiar. This was in the 7.4 video, and there was a spot where we ran into a sticking point. Okay. But the initial thought was with this question is at the time we didn't have any good identities for working with sine of x plus cosine of x. But maybe if we square each side, then maybe something else will pop up that might be a trig identity. Okay. And so let me remind you all what that looked like. When we squared each side here, and when you we end up with, on the left, we end up with sine squared x plus 2 sine x cosine x plus cosine squared x. Remember, we're FOILing here. And then on the right, when you square the square root of 2, you just get 2. Okay. Now, the place where a trig identity popped up is right here. Sine squared x plus cosine squared x is 1. So I'm going to go ahead and rewrite this as 1 plus 2 sine x cosine x. And I can keep going here. I could also subtract by 1 on each side. And so if I do that here, I get 2 sine x cosine x is equal to 1. And then we could divide each side by 2. Or actually, rather than dividing both sides by 2, this is actually another trig identity that we have here. This is one of the double angle formulas for actually for sine. So this is equal to sine of 2x is equal to 1. So we just need to figure out where on the unit circle sine is equal to 1, and that is only at pi over 2. And anything coterminal with pi over 2. So we have 2x is equal to pi over 2 plus 2 pi k. And all we need to do here is divide each side of this by 2, and we have our answer. And maybe I should say answers. So yeah, we have pi over 4 plus pi k. Right. So we only ended up with one formula this time. Now, here's the thing. Okay. Whenever you square both sides of an equation, there is a possibility that you can end up with what we call extraneous solutions. Okay? And so is what I'm trying to get at here is I don't think that these are all necessarily solutions to this equation. And there's a couple ways we could kind of check this. One is we could just check this on the calculator here really quickly, is we could plug in angles that look like pi over 4 plus pi k. Well, let's do that. So if I take sine of pi over 4 plus, and again, it's pi k. And let's just start off with -2, and we'll work our way up to maybe +2. Okay. So there's our sine, and then we want cosine of the same angle. And you can see when we plug in -2, we get this number here. And so you might be curious, is that the same thing as the square root of 2? And it is. There we go. But what happens when we plug in, say, k equals -1? Now we get minus the square root of 2. So this one doesn't work. Okay. Um, it's not a solution, is what I mean by it doesn't work. Okay. Now let's try and replace k with, say, a 0. Almost there. So you can see that did work. Okay. And now if I try k equals 1, we're going to see it doesn't work. And just to emphasize something here, let's try one more. Let's try with 2. Okay. And you might be starting to notice the pattern here for which ones of these work and which ones don't. But it's all of the even ones. And by even, I mean where k is even. So like if I tried 8 here, this will give me the positive square root of 2. Versus if I say try 9, an odd number for k, you will see that it does not satisfy the equation. It gives us that negative square root of -2. And this is all because we squared each side. Whenever you square both sides of an equation, again, you can end up with extraneous solutions. Okay. So down here, let's actually, rather than boxing this, note that um, when k is even, or maybe I'll say solutions, and then I'm going to say extraneous solutions. Okay. So the solutions again were when k was even, and the extraneous ones came from when k was odd. Okay. And so then the question becomes, is there a good way for us to rewrite the case where k is even? And it actually ends up there is a way that we could do that. Okay. And so if we wanted to do that, is what we could do is we could instead say that x is equal to pi over 4, but instead of plus pi k, we'll just say 2 pi k, because now we're just going to add even multiples of pi, not the odd ones. Okay. So this would be how we could write our final answer here. All right, and let's give this next one a try, and this will be our last one here. So with this one here, notice that 5/7, this is not a number or a y value that we're used to seeing on our unit circle. It doesn't correspond to one of those nice angles. So what we're going to do is we're going to start off by actually taking sine inverse of both sides. And now here's the deal is we did take sine inverse of each side. And so this is one angle that will make sine equal to 5/7. Remember, there is another one in quadrant 2 where we'll have the same y value of 5/7. Let me make a quick picture of that. So if I wanted to, I could sketch in the angle here of sine inverse of 5/7. Okay. But again, there is another angle where we will have the exact same y value on the unit circle, and that is right over here. There we go. And so to get this one, we just need to note that this angle here is pi, right? Half a revolution is pi. And that this angle here is actually the exact same as this angle here. Okay. So if I want to find that pink angle, is what I could do is I could say that it is equal to pi minus sine inverse of 5/7. That will leave me with the pink angle. Now, these two angles are just the angles that would make sine equal to 5/7 in between 0 and 2 pi. Okay. But remember, sine has a period of 2 pi. So I could just add anything that's coterminal with these two angles here. Or I could add a multiple of 2 pi. Okay. So from here, we want to divide each side by x. And I think I just said divide both sides by x. I want to solve for x, which means we're going to need to divide each side by 4. Okay. So this is one set of solutions. Okay. And we're going to have a second set. We still need to divide this one over here by 4. Let's go ahead and do that. We get x is equal to pi over 4 minus 1/4 sine inverse of 5/7 plus pi k over 2. Okay. Again, dividing both sides of the equation by 2. Okay. So these two lists will give us all the solutions. I'd say the only difference between how I did this and you might on the homework is usually they're going to ask you to round the highlighted part here to like 3 or 4 decimal places. But the way I have it written is the exact answers. They'll probably ask you to give the approximate ones. But you'll still write plus pi k and plus pi k over 2. Okay. But this right here does wrap up section 7.5.